Hey folks, welcome to Advent of Code in F# Day 3 already. The puzzle has just unlocked, so let's take a quick peek. Day 3 Rucksack Reorganization. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf did not quite follow the parking instructions, and so a few items now need to be rearranged. Each rucksack has two large compartments. All items of a given type are meant to go into exactly one of the two compartments. Okay, the elf that did the packing failed to follow this rule for exactly one type per rucksack. One item type per rucksack. Okay, sure, I'm going to need an example because this is a lot of words. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. Okay, so lower or uppercase are different item types. Sure, the list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its two compartments. That's a sentence I need to process more than once. So a line is a list of items for one rucksack. Cool. A given rucksack always has the same number of items in each of its two compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. Okay. So we have 6 lines, 6 rucksacks. Cool. And this is the first rucksack, yes. And if we split that in half, probably, like truly midway of the string, we get these two compartments. The only item type that appears in both compartments is lowercase p. Yeah, that's correct, but how does that link to all items of a given type are meant to go into exactly one of the two compartments? Okay, so if there's a p in one, there shouldn't be a p in the other. That's the idea, right? And this one has it, so that's a problem rucksack. No, they're all problem rucksacks. What? Okay, let's read on. Oh yeah, they didn't take the rule into account. For exactly one item type per rucksack. Okay, so every rucksack has one item that has the problem. Okay, now, okay, the penny has fallen, the penny has dropped. Okay, so that's clear. And then we have priorities. Sure. In the example above, the priority of the item type that appears in both compartments is whatever. So we give every letter a score, a priority, sure. And we sum those. Okay, so that's just to make sure that we have the correct item types, and then we just sum. Okay, that makes sense. So let's first figure out the problem items for each rucksack. That's a fun little puzzle and not too hard. Cool. Let me plop in the example. Let's see if we can read it correctly. That looks like our 6 rucksacks, so let's go. I'm thinking about data types. Do we just keep working on strings? Yeah, maybe just sprinkle a bit of type or above it, but let's keep it as strings, or at least as arrays of sequences. No, let's first maybe take a look at the input. If it's really, really, really long, we might have to think again about this. Oh, this looks okay. I think a brute force approach without too much optimization might just cut it for today. So I'm not gonna worry about the optimal algorithm or the optimal data structure just yet. Let's first play around with the problem a bit. First I'm gonna write a function to parse one rucksack a bit, or to detect the problem item in one rucksack. So let's play around with a single rucksack. Let's just play around in a REPL a bit. How do we split it into its compartments? We need to Yeah, split it in half probably. So let's figure out the length. So how do you type rucksack in English? I'm not a native English speaker, so CK. Okay. There we go. Are they all even? That's maybe something to quickly check. If there's like a off by 1 chance, we would like to know it early. And so let's group them by. No, let's just print it out. Let's see if these are all evens. If we do the listed, I'm hoping we see everything. We see enough. Those look like all even numbers. So yeah, there's no off by 1. Probably no off by 1 in there. They're all even. Cool. So we have compartments that are easily split. Rucksack. How does split into chunk work? Does that neatly split it into 2? I'm actually not sure how split in 2 works. Splits the input sequence into at most count chunks. So it splits whatever a sequence into at most 2 chunks, but how does the splitting happen? It looks like exactly what we need, but let's make sure that it is exactly what we need. This function returns a sequence that digests the whole initial sequence as soon as the sequence is iterated. As a result, that's not what I'm looking for. It looks like it tries to neatly split the sequence into like best effort chunk. Let's go with good enough. Maybe let's take a sneak peek at how it's implemented. What do we do with count? It uses array split into. Okay, that's too deep of a dive. Let's forget it. It looks good. It looks good. I'm gonna lift everything into the list space again, not to grapple with arrays. There's no real reason to do it actually, but I prefer lists. And we're still parsing, so if we do it once for the entire input, it shouldn't hurt too much. And make everything lists like this. So now we have our 2 compartments, and now we can look for the problem. Let's make a quick type. Nah, it's too much of a hassle. It's just 2 substrings. Cool. Or they're already turned into 2 lists of characters. Fine. And let's look for the problem. Yeah. Problem item. Yeah, let's call it problem item. Problem item. Let's iterate over one of the 2 compartments. Yeah. So we have a compartment A and compartment B. Auto-completion can stop confusing me now. Compartment A and compartment B. And that should be, I'm destructuring the list, so we have both lists in a variable, or both compartments in a variable. And now we can just write a for comprehension or a for loop basically over all the items in one. So for item in compartment B. Or why would I start with compartment A? B, that's silly. Let's go with compartment A. Is this how you write a for comprehension in F#? I'm not sure, but it seems to work, so I'm going with yes. Yeah, that's it. So if compartment B contains this, we have found our problem item. What's the yield? How do I return something? Wait, is it like this thing? Do, then yield? I'm pretty sure you can do what I'm trying to do here. Yeah, there we go. So this gives us a list with violating items, but there should be only one. There should be only one according to the problem description. So I think we are done with finding the problem items. There we go, we have P. So this is parsing, this is finding a problem item. What's the next thing we need to do? Give it a priority. That looked like a potentially easy. No, that's not. Yeah, we could do it potentially easy. So let's write a function for it. We need to calculate priority for characters. So I'm gonna give it a type. And priority for A should be what? 1. Priority for Z should be lowercase c, sorry, 26. Capital A is 27. And capital Z is... Where's capital Z again? There, 52. You know what? Let's put those into tests. Let's keep those for posterity. There we go. There we go. Okay. I'm gonna load everything into my REPL. Apparently I forgot to include my unquote dependency. Oh, I see exceptions. That's not something I would expect. Oh yeah, that's a failing test. That's something we do expect actually, so we're good to go. It's funny that I need to write tests for converting a character to an int, but not the other parts. Sometimes I can't even explain my thinking to myself. But let's see. So if we convert the character to an int, we get 97, and we would like 1. So if we deduct 96, should we get there for all our lowercase items? We do for the A, we also do for the Z, so I'm gonna take that as a, we probably do it for all. But capital A is something else. That's a shame. That's harder than it has to be. Okay, that's not a problem. So I'm gonna literally keep it simple and say if item, or there is a car, there's is lower, then we do the lower thing, and otherwise it is minus what? 65 minus something should be 27. It's too early in the morning to do math. 65 minus 27, 38. Let's give that a go. So this should still work for lowercase. Yes, it does. Does it work for uppercase? It does. Does it work for Z? It does. I'm calling this a night. Looks good. I'm going to drop those tests into my test runner. My lightweight test runner, at least. It's just a function. There we go. Why are there green squigglies? Because formatting duplicated code again. Still have not looked into why that's happening. But I think we have everything in place now to actually go ahead and solve part 1. So that's splitting into compartments. Let's call this part parse. So this part is parsing. Yeah, I'm gonna return the tuple. So we always have 2 compartments. It's a lightweight way of having something of a type in there. So we can parse a rucksack, and then we can find a problem item. A rucksack is a tuple of 2 compartments. There we go. And we have our priority. Yeah, so let's see if it works now. So we have our rucksack from the example, and we can parse it. And we can find a problem item. And we can give it a priority. And that should be the P. And it's 16. It is 16. So let's do this for the example now. So let's do this for every rucksack in the example. I'm thinking, can I use why is this not working? It is working. Okay, cool. So we need to do this now for every rucksack in our example at least. So let's do example and do a list.map. So we're doing this for every rucksack in the example. And we have 16, 38, blah, blah, blah. 42, 22, 2019. That looks correct. And now we need to sum it. And we should get our nice 157. Yeah. I'm writing another function. There we go. So this should solve, and our solve for the example should be 157, or what was it? It was 157, right? Why is it not working? Interesting. Oh yeah, because it's not 52. Sorry for that. It's 6 o'clock in the morning when these puzzles unlock in Belgium where I live. So this is the weekend effect. Yay, testing done. It works for the example, so let's try it for our input. We get a somewhat reasonable number. Let's see if it's correct. It's correct first try. Good job, us. So what does part 2 have in store for us? As always, I'm copy-pasting my file so I can forget about part 1 and break stuff in anger. My eyesight is getting bad. I can't read the text. There we go. Part 2, let's take a quick peek at what we're being asked. Oh, of course, there's another issue For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. Okay, if a group's badge is item type B, then all 3 elves will have item type B somewhere in the rucksack, and at most 2 of the elves will be carrying any other item type. I'm going to need examples again. Let me parse it quietly for a second. All 3 elves will have item type B somewhere in the rucksack, and at most 2 of the other elves. Nope, that's too difficult for me. The problem is that someone forgot to put this year's updated authenticity sticker on the badge. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. So we need to find the badges, cool. And there's this little constraint about elves with the same badge, okay? Nobody wrote down which item type corresponds to each group's badges, so we don't know which items the badges are, cool. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group. Every set of 3 lines in your list, what does that mean? So in the above example, the first group's rucksack are the first 3 lines. Okay, so it's literally grouped them by the 3 subsequent lines of 3 or one group. That's easy. Okay, so every group is 3 subsequent lines. Cool. And then we find one item type that appears in all 3 rucksacks. So that must be the badge. This sounds actually very doable. I was already there was like a bead of sweat dropping, anticipatory sweat dropping, but I think this is actually pretty doable. We just need to look at sets of rucksacks, find a common item, but a common item in 3 instead of in 2, and that's it. That's pretty doable. So that's parsing a single rucksack. The only difference is, and it's not a problem item, it's a badge, and we need to look at 3 instead of 2. Yeah, it's doable. I'm gonna call find problem item, find badge. Oh, wait a second. There's compartments in this thing. I don't think we need compartments in part 2, right? Only item type carried by all 3 elves. Yeah, I think we don't even need to worry about compartments. I don't think we need to worry about compartments. That's interesting. Yeah, let's give it a go. So a rucksack is a string basically. So let's keep it a string, or let's build a list of of characters from it, but that's all we're gonna do. You know what? Let's keep it a string. Let's keep it easy. Find badge into a group. Find badge of a group. I'm gonna hardcode the 3. I'm gonna hardcode the 3. Is and not how I do and? Is and how I do and? Probably. We don't need to parse into compartments. We just need to group by 3. yeah, we just need to group by 3. How do you do grouping by 3? There's a nice little function called chunk by size, and I think that's exactly what we need. If we say chunk by size 3, it splits a list or a sequence into chunks of length 3. So these are our groups. Yeah, these are our groups. And then for every group we can find a batch. And we need priority, that's it, probably. Sounds too simple, but yeah, never stare a gift horse in the mouth. Is that something people say in English? It's something we say in Dutch at least. So let's see if we can find the batch in our groups. I'm gonna start with just the first group. We have a group. Can we find a batch? Is our thinking sound? Is R the batch? R is the batch. Is Z the second? Z is the second. That's it. So let's do groups. Find our badges, and after we find a badge, calculate its priority and sum it. There we go. That's a nice round 70. That is correct. So I'm going to use this as a solve. So let's make groups out of the input and then do the same thing, and solve, for example, should give us 70. It does. Let's add a test or change this test. So that's just for fun, because actually I think we are done. We get a somewhat smaller number. Okay. I was panicking for part 2, but part 2 was actually very straightforward. Cool. Let's quickly go over what we did for, what's the puzzle's name again? Let's quickly go over the rucksack reorganization. What did we do today? We explored the list and the sequence functions, actually. We used split in two, we used destructuring, we used for comprehensions. I don't think we've seen that this month, so that's a nice way to handle sequences, or to generate sequences from other sequences. I think this was the hardest part for me personally, converting a character to a number. We did some, what's this called? Function composition operator. That's something I don't think we have used this month, so that's also something new. And then the most important thing was realizing that part 2 was actually easier than I anticipated, but when I started reading the problem. We did not need compartments anymore. We just needed to split our rucksacks into groups of 3. So yeah, once I had that realization, things flowed nicely. Fun little puzzle. Usually these weekend puzzles are a little harder. This one was okay. It was a lot of fun, at least. So I hope you had fun, and I will see you tomorrow for Advent of Code Day 4. Bye bye.